Hello friends, welcome in the video number 5 in the series of building the mostly printed CNC machine. In the previous video we did build the frame and assembled all the parts together. In this video I'm going to do the electronics and load the firmware and do the basic wiring, and I hope we will do the first run test. It will be a long video, but with a lot of good information, so please be patient. As we previously talked in the first video, when you are preparing yourself to build your machine, and if you read in the official website, you will find that you have two options. A machine that works without an end stop, and a machine that works with a dual end stop. The main difference between them is that the dual end stop machine makes it easy to direct the gantry to the 0 point for performing repetitive tasks, or when you are going to change the milling cutting bit. And depending on these two choices for the electronics, a machine without an end stop, all the boards will work for you, starting with the Arduino Uno with a CNC shield and 3 stepper motor drivers, or Arduino Mega with a ramps board with also 3 stepper motor drivers, or any of the developed boards of the Mega family like the Mini Rambo or the Rambo boards. But a dual end stop machine work only with Arduino Mega with the ramps board with 5 stepper motor drivers, or any other developed board of Mega family which are supporting 5 stepper motor drivers and more, like the Rambo or even the Archime board or any other board like them. Also, I want to mention that the method where you are going to run your machine also affect the board you are going to choose. Let me explain. We have two main system, or firmware as it's called. We can load this firmware to our boards. The first one is GRBL or Gerbil. The Gerbil firmware mostly used with the Arduino Uno board, and the second firmware is the Marlin, which is mostly used in Arduino Mega family boards and developed boards from it. Where in Gerbil the board is connected to the computer via a USB cable, and the machine is controlled through a CNC controlling program like a CNC GS or the STLCAM, or even some general G-code senders like the repeater host. As for Marlin firmware, you can control the machine such as the GRVL by connecting the board to the computer via a USB cable. Also, you have a very good benefit by connecting an LCD screen with a built-in SD card reader to the board, and by putting the job, I mean the G-code file, on an SD card, you can run the machine for a long hours independently of your computer. I want to mention here that if you did buy the electronic kits from the official store of the machine, they prepared everything for you. Just go and wire the motor to the board and you are ready to go. Back to me. I choose to go with a machine with a dual end stop that works with Marlin firmware, and I choose the Arduino Mega 2560 board with ramps 1.4 board with 5 stepper motor driver, the DRV8825, Also, I'm going to use the full graphical screen 128/64 LCD with a built-in SD card to load the job from the SD card. As for the Arduino Mega 2560 board, we only care about knowing the USB connection port and the USB cable, which is similar to a normal printer cable, and they come in general as a set. Also, it is better to use a base for the Mega board. It is best to mount it from now for a better management. For the ramps, first I'm going to mount it to the Arduino Mega, and later we will talk about it in details. When you are going to mount it to the Mega, be careful for the pins that no one of them is bent or misplacing, and if there is something misplaced or bent, try to adjust it with your hand. After making sure that all the pins are in place, press both boards together so that all pins completely installed. For the ramps board, it is important for us to know the following. First, we have to know the power terminals and the polarity. If you hold the ramps board in this way, the closest to you will be the main power for the board itself. And we are going to connect 12 volt 5 amps minimum power to power the board. These other two are for the heated bed and the nozzle if you are going to use it as a 3D printer too. And in that case, you have to connect a 12 volt 11 amps a minimum power for that. Secondly, depending on the firmware you are going to install, we have to install the jumpers, which are those, for all stepper motor drivers. These jumpers are to determine the micro-stepping value that the motor will work with it, and it is related to the firmware. In our case, the designer made the firmware to work with 32 micro steps, so we have to fill up the 3 jumper for each stepper motor driver. I'm going to repeat this for all the drivers. Thirdly, the installation of the DRV 8825 stepper motor driver in place. Here we pay attention to the driver alignment so that we match one pin between the driver and the ramps board. As example, when you are flipping the driver, there are, let me focus here, the pins are labeled. So we have EN, enable, or the DIR, the direction. You can match those pins to the board. Also, as you can see, the DIR and the EN. So using one of them to do the right alignment between the driver and the board. And often the alignment of the driver is so this potentiometer is toward the power terminal of the board. And later, if you have the driver not installed in place because the narrow space, you can apply some sanding or filling this side a little bit to sit in place. Also, it is better to install the heatsink in place to make sure that it does not touch any soldering point or any other component on the driver. The driver kit for me came like this. The heatsink and the driver came as a kit. So just installing it, and be careful, as we said, that the heat is not touching anything. Now I'm going to install the stepper motor driver to the ramps board. As we said, the direction pin is aligned to the direction pin on the board, and applying simple pressure to set it in place. Before proceeding further with the connections and wires, we must do two important steps. One is to adjust the voltage reference of the stepper motor drivers, and later we have to load the firmware to the board. First, we have to adjust the voltage reference, or the VREF, of the stepper motor driver to fit our stepper motors. Otherwise the motors will not work well, and you will hear cracking sounds, or even the motor will not rotate at all if the voltage is not correct. And according to the documentation of the DRV 8825 stepper motor driver, we have the following equation. the current limit equal VREF time 2. So the VREF equal current limit of the stepper motor divided by 2. So go back and look to the specification of your stepper motors. For me, I have a value of 1.7 amps as a current limit for the stepper motors. So the VREF for me will be 1.7 divided by 2 and equal 0.85 volt. To adjust the voltage reference of the stepper motor driver, you are going to need the following. A multimeter, any quality is meeting the purpose. A small screwdriver with a flat head, approximately 2 mm. The potentiometer on the stepper motor driver may look like it needs a Phillips screwdriver, but no, the flathead screwdriver is fitting better. Also, we need one alligator cable clips and the USB cable for powering the Arduino Mega. This came with the kit I bought, but it's short. I'm going to use the regular printer USB cable. It is longer to reach my laptop. And also we need a power supply to power the RAMS board, as we said, at 12 volt with a minimum 5 amp. I'm going to use an old ATX power supply, a PC power supply. As you can see, it gives in 12 volt 15 amps, and it is more than enough. I did a simple connection. As you see, the yellow are the 12 volt, the black is the ground, the 5 volt wires, the 3.5 volt wire if I'm going to need them in the future. First, plug the USB cable to the Arduino USB port. Then to your computer or a laptop. This is just to power up the Arduino board. Also, plug the power supply to the power terminals of the RAMs, and pay attention, of course, to the polarity. If you can see here, this is the negative, the ground, and this is the positive, the 12 volt. I didn't turn on the power supply yet. Now put the multimeter on 20 volt DC. Connect the positive lead, which is the red one, to one of the alligator cable clip, and the other end of the alligator clip to the metal piece in the screwdriver. Put the negative lead of the multimeter on the negative terminal of the ramps, and put the small screwdriver head on the potentiometer of the stepper motor driver. Be careful to not touch anything else. I'm going to turn on the power. As we said, the negative on the negative terminal of the power ramp, the positive, which is now the screwdriver, to the potentiometer. And now the reading that appears on the multimeter screen is the current VREF value of the stepper motor driver, which came from the factory. Now, by turning the screwdriver to the left or to the right, we are changing the VREF value. A slight turn is changing the value. For me, my goal is 0.85 volt, as we get in our equation. That's it. Repeat the process for the other stepper motor drivers and make all of them the same voltage. Of course, some are preferring to make the actual VREF for the stepper motor drivers less than the value of the equation by 5 or 10% in order to avoid overheating the motors. But I will keep it as it is now, and I will monitor the motor's temperature at the testing time, and if I noticed any overheating, I will back and reduce this value to 0.8 or less if necessary. We have finished tuning the VREF for the stepper motor drivers. Unplug the cables. And after that, I'm going to my computer for the next step, which is loading the firmware to the Arduino Mega. Now we are going to load the firmware to our Arduino Mega board. First, I'm going to download the firmware. As we said, the designer has prepared the firmware for us. Go to the official website of the machine, the v1engineering.com, and to the branch of the mostly printed CNC machine, to the electronics page, and under that go to the firmware. As you see, first you see that you have some warning in the page. It says that if you bought the bundle and the electronics board from the V1 shop, this is already done for you. But as I said, for us or for me, I'm going to download the firmware. In this page you will find very good information about how to flash firmware for other type of the boards, like the Rambo, Mini Rambo, the Ramps, or the Smoothie, or even the Archime. And now back to our firmware. You will find all the versions of the firmware under the page of the V1 Engineering in the GitHub website. So if you clicked this link or this, it will take you to the GitHub website. And this is the page. The GitHub is changing the form of the page from time to time, but not important for us. This is the designer's page for the Marlin firmware. He had prepared many versions for all the boards and all the machines he had designed. You can read to understand what each version it means. I'm going to go through them here. So go to choose the branch or the version of your machine. As you see, you have the firmware for the mostly printed 3D printer, or the mostly printed CNC machine, or the other older CNC versions. Now for us, we need the mostly printed CNC machine, so we have all this version. And for me, because I'm using the ramps board, I'm going to choose one of these. Let me read the name, and depend on that we decide which one we are going to download. As we said, this is for the mostly printed CNC machine, suitable for ramps board, for the T8 lead screw, for the 60 teeth pulleys. If you have 20 teeth pulleys, you have to change the firmware depending on that. Of course, also this is for the supporting the LCD screens, and because this is for the ramps board, the name says it's supporting the 22 micro stepping. And also you see in the end of the version's name, this is for the dual end stop machine, and this is for the machines without end stops. So I'm going to download this version, or to choose this version. Now in this page we have an information about this firmware. Don't bother yourself for that. just go to the clone or download button, click on it, then go to the download zip file, click on it, and it's now asking to save the zip file. I'm going to save it on desktop. It takes no time. After downloading the firmware, we must download also the Arduino IDE software from the Arduino.cc website. The Arduino IDE software is free software, so go to the software download page, and depend on your and which operating system you are working on, download the version suitable to you. I'm going to download the Windows version. It will work for Windows XP and up. Click on it, and it will take you to this page. As we said, Arduino is a free software. You can support them by donating a little amount of money, or just go to this button just to download the Arduino IDE software. It will ask you to download. I already downloaded it because it will take a little time to download. The size is about 200 megabytes, so just download it to your PC. Now we have the Arduino IDE and our firmware. Just go and install the Arduino IDE software. I'm going to run it as administrator. It's preferable to leave all the options as a default, and during the installation it may ask to download or to install some drivers for the USB and the connections. And by the way, because the Marlin firmware is depending on Marlin 2, so if you have an older version of the Arduino IDE, it is recommended that you update it to the last version, minimum 1.8.9. So now the Arduino installation completed. I'm going to close this message, and for the Marlin firmware, just unzip the file. We unzipped it. Go inside that folder, and from that to the Marlin folder, and open the Marlin Arduino file just by double clicking on it. It will open automatically the Arduino IDE software. As you can see, this is the Arduino IDE software. Here it doesn't matter if you have any previous experience in Arduino programming. We are just going to use the IDE software to load our firmware to the Mega board by following a few easy steps. First, we will do some configurations. From the tool menu, go to the board command and select the Arduino Genino or the Arduino Mega 2560 as our board. After that, from the tool menu, go to the processor and select the Mega or the Mega 2560 also as our processor. Also, we need to add a library to support the LCD screen. So go to the sketch menu and to the include library command and click on the manage libraries, and from the appearing window in the search box write u8glib .h, and in the search result may appears more than one name, but we need this file exclusively because Marlin has been programmed on it by name, and an error message will appear during the upload if you choose any other library, even a newer version like this. So we are going to install this. Press on the install button and wait to the process to the end. Now the library has installed to the Arduino IDE. Close the window. By doing this, we have finished the Arduino IDE configuration, and we are ready to upload the firmware to the board. Now bring the electronics as they are. No need to power the ramps in this step. Just plug the USB cable to the Arduino Mega board and then to your computer or laptop. You will find that the ramps or the Arduino Mega is now on, and make sure that the Arduino IDE has found our board by going to the tool menu, the port command, and you find that there is one port has been set automatically. The port number is not important here. It may be different from mine. It's depending on your computer. But the very important point here, make sure that the only board connected to the computer is this one, that we want to upload the firmware to it. It should not be any 3D printer or any CNC machine or any other Arduino board connected to the computer at this exact moment, except for our board. Now just go to the upload button and click on it. You will find that the Arduino IDE has started compiling the sketch, and the progress bar is showing you the progress. It may take a little time. We will wait for some time until the compiling and then the uploading to the board ends. Now it's telling that it is uploading. Now it's done uploading, and if everything go well, some lines in the message window will appear and telling us the upload has finished, and the number determine the firmware size on the board's memory. And that's it. We have uploaded Marlin firmware to the Arduino Mega. Just unplug the USB cable from the board, and we will go to wiring the machine. I hope that you do not go into any problem in this step. And in any case, if any error message appears telling you that the port is not connected, or the process is not suitable, or even that there is a missing library, just close the Arduino IDE, unplug the USB cable, wait a moment, unplug the USB cable again to the board, and redo the configuration of the IDE. And also, in some cases, if the Arduino Mega is a clone one, it's not original, may it not find the port automatically. Just select the available port. As we said, it will be the only board connected to the computer at that time. Now that we uploaded the Marlin to the board, we are going to complete the connections for the electronics and do the main wiring. Now back again to completing the connections. I will connect the LCD screen to the RAMs board first by placing the extension cable adapter in place. As you can see, it also have a group of pins. Just make sure everything is aligned and in place, and press it down to the RAMs board. This was the adapter for the cables which will be connected to the screen. One of them is for the screen, and the other is for the built-in SD card reader. Now for the cables, on the screen generally the labels are clear, and of course there is the pin code for pin number 1. So this is the EXP1 and this is the EXP2. But in my case, the adapter, it really does not show any labels. There is some labels, but it's hard to read. I can tell that this is the EXP1 and this is the EXP2 if you look closely. I will do it depending on that. So this will be the EXP2. And this will be the EXP1. But if you cannot figure out the cables order, do not worry. Plug them anyway, and then if the screen does not light up at the first running, just unplug the powers and swap the cable places on the adapter. The screen will not damage if the cable are swapped. Now we are going to wire the motors and the end stop switch to the RAMs board. I want to mention first that the wire came with the motors are about 1 meter long. They are short for my machine. I ordered 2 meter long cable. Also, I think they are short, but they are enough for the testing now. I will do the wire management later. And because the wires also for the end stops are short, I'm not going to mount them in place on the roller plate. I'm going to let them free just for the test, as I said. On the machine's frame, the motor near the zero corner is the motor number 1, and the far from the zero corner is the motor number 2 for the both X and Y axis. So I labeled the wire out of the camera to not be confused later. For the ramps board, those are the stepper motor drivers, the X1, Y1, Z, X2, Y2, and the pins for connecting the wires are those 4 pins for each stepper motor. For the X1, Y1, Z, any one of these is work, X2 and the Y2. And also I will connect the wire so that all the colors will match in order on the ramps. I'm going to wire them so the red wire is toward the power terminal of the ramps. And for the end stop switch, the wiring will go to those pins, as you can see in the picture too. And it depends on what type of end stop switch you have. So if you got similar to mine with the board and 3 wire, the connection is according to the color. The red goes to the positive, the red goes to the positive, the black goes to the negative, and the green go to the signal. This is the X1, will be the first vertical 3 pins, like this. And in the order of that, this is the X1, the X2, Y1, Y2. If you are going to use a Z probe, you will do this for the Z probe wiring. And if the end stop switch are of the type with 2 wires, black and white generally, you will connect the 2 wires, one of them to the middle is the negative and the other to the signal, the top one. And the polarity does not matter here. And also to prevent not touch any pins by mistake when I'm going to run the test, I will mount the screen to this piece. I found it on Thingiverse. It's a simple one just to hold the screen in place without touching any pin by mistake. Now I'm going to put this on the machines table, power the ramps board, and I'll connect the wires to the motors and continue from that. As you see, I just fixed the screen with the table with some masking tape. I'm going to power up the power supply again. This is the second run. see that I have some dead pixel, or the screen is bad, but I don't think it's gonna to affect the work of the CNC. Let us go through the menu and make some preview. Info screen, motion, temperature, configuration. So I'll go to motion and try to move the motors. Of course, I will start with a small movement and control the two motors on each axis are moving in correct direction. So let's start with move axis, move the X, move 1 millimeter. There is a movement. Yes, both of them are moving in the same direction. Let's go to the Y, or first yes, also both of them are moving in the same direction. Let's go to the Z. I'm giving it a positive value. It's going close to the table surface, and that means that there's only the Z-axis. The wire must be flipped on the ramps board to give the correct direction for the movement. Because the default is that if you give it a positive value, the tool must go far from the surface of the table, and my machine now is doing the opposite. So I'm going to cut the power and just unflip and just flip the Z where it's hard to work with one hand. I feel some heating, but I don't know if it's normal or not. I'm going to power it again. Going to the Z, and let's see. Yes, now it's working as it should be. I'm giving it a positive value. It's go far from the table surface. I'm giving it minus value. It's going down near to the table surface. Let's do bigger movement. The axis. It's not going in the minus for the x-axis. I think that's logic. I'm going to moving the y-axis by 10 millimeter. Also, it don't go beyond the 0 in the minus. Yes, our machine is live. I'm going to attach this piece is pen mount piece. I'm going to mount it to the tool mount part and attach a pen to it and do the famous crown test. I will attach the pen and I will be back. I did attach the pen to the tool mount and I put some paper to the table. I have the G code for the crown on the SD card. As you see, the media inserted. I'm going to the print from media. We have only one file which is the test crown with the speed of 12 millimeter per second. I'm not going to put the pen to the paper. I will run the test crown in this position, so if something go wrong it will not damage anything. Let's press start. Start, as you see, start print. Yes, print. I'm going to monitor the stepper motor's temperature, as I said before. Just to see if the VREF value is good or not. Yes, that's it. Finished in 2 minutes 26 seconds. Now let's do the real test. So go to the motion, move axis. Because I don't have the end stop switch installed in place, I can't use the auto home command. I'm going to guide the gantry manually to the position I want to. It is not going further on the X, so I'm going to turn off the power and do it by hand. I think this is a good start. As you see, the pen mount piece, it's flexible, so I think it's good here. it says that x0, y0 and z0. So this is the 0 point now for the job. Let's go through the menu to print from media or the test chrome. Are you sure you print? The quality of the line is not good, I think, because the pen is just attached using the zip ties. Also, there is some squeezing. It's pressing the pen, as you can see, the pen mount is pressing too much on the paper. But the machine is working just as it should work. I can feel a very little amount of heat. I think I will the job end. I'm going to reduce the VREF value, but as you see, our machine is live. I'm going to finish the video here. I hope you enjoyed this video. I haven't finished with this machine yet. I have planned a lot of things to do with it. If you want to complete the journey with me, please subscribe to the channel if you didn't have yet, and hit the bell button to get notified to the upcoming videos. And if you liked this video, please like, share and leave a comment below. Thank you for watching. See you in the next video.